Hey guys, it's me again. So I just had the best weekend. My mom made cookies and I got to eat them. And as I was eating them, it kind of got me thinking. Baking and chemistry are a lot alike. When you bake something, you don't just put a little bit of this and put a little bit of that in there and then hope for the best. No, you carefully measure out the ingredients and follow the instructions. Chemists do the same thing. A chemical equation is like a chemist's recipe. A balanced chemical equation tells a chemist how much and what to put into a reaction and what will come out. Here are a bunch of chemical reactions. The starting materials in any reaction are called reactants. Reactants are any compounds to the left of the arrow. Reactants are like the flour, sugar, and butter in a cookie recipe. Everything to the right of the reaction arrow are called products. After mixing and baking flour, sugar, and butter together, cookies are the end product. Well, you should end up with cookies. Balancing chemical equations is important, but why? Well, chemists are not only like bakers, but they're also like bankers. Bankers count money, and chemists count atoms. Chemists are concerned with efficiency, supply, and demand. Waste costs money. They want to make sure they have the most bang for their buck in every chemical reaction. This is also why the law of conservation of mass is so important. Chemists want to get out as much as they put in a reaction. You wouldn't use a whole sack of sugar if the cookie recipe only called for a half a cup, would you? No. Not only would your cookies taste disgusting, but you would have to throw the whole batch away. A balanced equation is key to getting the recipe right. Matter will undergo a physical or chemical change in a reaction. But the amount of matter from beginning to end doesn't change. So there are two words that you probably heard your chemistry teacher ramble on about: coefficients and subscripts. Let me break it down for you. This is a balanced chemical equation. If you're like me, you notice that there are some big numbers and some small numbers. The big ones that go in front are called coefficients. The little numbers are called subscripts. Sub means below. Think submarine. The little numbers go below the rest of the text. Okay guys, this is super important, so pay attention. The coefficients always go in front and apply to every element in the compound. Subscripts only go with the atom to the left. Check it out. On the reactant side, we have two coefficients. The coefficients tell us there are really two NH3 molecules and three I2 molecules. On the product side of the equation, there are two Ni2 molecules and three hydrogen molecules. So you can picture the reaction like this. The law of conservation of mass says there are just as many nitrogen, hydrogen, and iodine atoms on the reactant side as there is on the product side. Bankers always check their money more than once. So let's double check to see if we're balanced. I'll show you how it's done. Anytime I need to balance an equation, I just make a table, like this one. First, write the symbols for all the elements present on the reactant side and the product side. Then count them up. The 2 in front of the NH3 tells us that there are 2 nitrogen atoms and not 3 but 6 hydrogen atoms on the reactant side. Having a 2 in front of it is like multiplying every atom behind it by 2. 3 times 2 is 6. So there are also 6 iodine atoms on the reactant side. On the product side, there are 2 nitrogen atoms, 6 hydrogen atoms, and 6 iodine atoms. Okay, we've double checked, and since there are equal numbers of all types of atoms on both sides of the equation, we can say that the reaction is balanced. The law of conservation has been met. So this equation was balanced for you, but most of the time, you're going to be given unbalanced chemical equations, which is where the reactions have no coefficients in front of them. Remember, you can change the coefficients, but never the subscripts. Here's an example of a combustion reaction. To balance the equation, make a table. Every time, trust me, it's so much easier this way. When we count the atoms, you can see that although there are equal numbers of carbon on both the reactant and product side, the hydrogen and oxygen atoms are way out of whack. We can place coefficients in front of the individual compounds to balance the equation. Balancing equations is all about trial and error. Sometimes you're gonna mess up, but then you just start over again, and hey, that's okay. It happens. It's kind of like whenever your cookies turn out flat. It happens to everybody once in a while. The cool thing about balancing equations is that you can start anywhere. You just pick one atom, balance it, and then move on. Let's look at just the hydrogen. There are more hydrogen atoms on the reactant side than the product side. We can add more atoms, but we can't take any away. The hydrogen is present in the water molecule. To get more hydrogen on this side, we can write a coefficient in front of the H2O. If we add a 2, how does that change the equation? Now we have 4 hydrogens on the product side and 4 oxygen atoms. So we need to update our table. So that took care of the hydrogen, but the oxygen is still not balanced. Look at the reactant side of the equation. Now, more oxygen is needed on the reactant side. Where can we put a coefficient to balance this reaction? That's right, in front of the O2. Now we need to update our table again. Now there are equal amounts of carbon, hydrogen, and oxygen in this equation. And we now have a balanced reaction. Here is a picture of a balanced reaction for you visual learners. You can count the atoms and see for yourself that the law of conservation of mass checks out. Hey, you're pretty good at this. You could probably be a chemist. Well, you may not want to hear this, but the only way to get good at this whole balancing equations thing is lots and lots of practice. There's no trick to it. You just gotta stay focused and keep at it. Okay, well, that's all for now. See you next time.